Welcome to Chapter 2, where we will be talking about atoms, molecules, and ions. So our goal for our first section, we're going to describe electrons, protons, neutrons, and the structure of the atom, and look at terms like the atomic number and mass number. So atoms have smaller subatomic particles. They can be charged, so they can be a positive or negatively charged subatomic particles, and neutral subatomic particles. The positive charged ones are called protons. So protons are positive. The negatively charged subatomic particles are the electrons. And our neutral ones are our neutrons. So the electrical nature of the atom was crucial to discovering its subatomic structure. So there are some laws of electrostatic attraction that we need to know. We need to know that like charges repel and unlike charges attract. So opposites attract. So if I have two positively charged ions, they're going to push away from each other. But if I have a positively charged, what we're going to learn is a cation, and a negatively charged ion, which is an anion, they will attract to one another. Same with protons and electrons. So the positively charged nucleus and the negatively charged electrons around it are attracted to one another. And if I have two electrons, they want to push away from each other. So here we go. We've got our electron, which are located outside of the nucleus and have a charge of -1. Our protons, which are inside the nucleus, have a charge of +1. And then we have our neutrons, which are also inside the nucleus, and they do not have a charge. They're 0. Also look over here on the far right side when we look at the relative mass. Our protons and neutrons each have a mass of 1, so they have equivalent mass. Notice the electron. The electron, it would take 1,836 electrons to have the mass of 1 proton or 1 neutron. So it is so small that we count it as being negligible. Because even if you look at the periodic table, if there's 118 elements, so if we looked at that largest element with 118 protons and 118 electrons if it was neutral, that would only be 118 is not even a tenth. 118 electrons is not even a tenth the mass of 1 proton or 1 neutron. So, looking at this, here's our atom. Atom is mostly empty space down here. We know atoms are extremely small. 1 teaspoon of water has 3 times as many atoms as the Atlantic Ocean has teaspoons of water. Isn't that crazy? So that just kind of gives you some perspective. Now, if you're looking at the periodic table, can you look at your periodic table? Let's look at this guy, carbon. This top number here, this is its identifying number. That is its atomic number. The atomic number also tells me how many protons it has. So the atomic number. Then we're also given its elemental symbol. Sometimes symbols are 1 letter or sometimes they're 2 letters. If it's 2 letters, the first one is always capital and the second one's lowercase. Then down here, we have our average atomic mass. Notice it's a decimal. That is not its mass number. That's an average number, and we're going to get more into that in just a little bit. Now, notice also right here, we say relative mass. We count 1 proton, 1 neutron as each having mass of 1. But the actual mass of a proton and neutron is 1.67-ish times 10 to the negative 24th grams. So very, very, very small. What they did, though, is to make it easier, is we said that, well, that mass is equivalent to, we're going to say it's equivalent to 1, just because that number is so small. All right, so let's look at protons. Protons, like I said, defines the identity of an atom. So pause for a second here, and I want you to try to look at the periodic table and figure out how many protons are in bromine, how many are in magnesium, and how many are in cesium. Hopefully for bromine, if you found it on the far right-hand side, it's in the 4th row on the far right, number 35. It has 35 protons. Its atomic number is 35. Magnesium is on the left in the 3rd row, the 2nd column. It has 12 protons. And cesium, way down in the 6th row, 1st column, has 55 protons. Can you look at your periodic table and tell me which atom contains 34 protons and which one has 11 protons? Pause the video here real quick so it gives you a minute to look. Did you get Se, selenium, and Na, sodium, for 35 protons and 11 protons? How about these? Which atom has an atomic number of 56 and how many protons does it have? Pause the video and see. Did you find barium, Ba, and if its atomic number is 56, it also has 56 protons. Hopefully that didn't trick you. All right. Let's look at electrons. Ionic charge is due to imbalance in the number of electrons and protons. Remember, the protons can't change without changing the identity of the atom, so the number of electrons change to make this happen. If an atom is neutral, then the number of electrons equals the number of protons. Think about it. If I have 8 protons, which are positive, and 8 electrons, which are negative. So if I have equal numbers of protons and electrons, then 8 minus 8 is 0. So it's neutral. If we have an imbalance, so let's say I have more electrons than protons. So let's say I have 8 protons, and if I have more electrons, let's say I have 10. Instead of 8 negatives, let's say I have 10 negatives. So what is positive 8 minus 10? That gives me a negative 2 charge, right? So I gained electrons. I went from 8 electrons to 10 electrons. So if I gain electrons, I then become negatively charged, which is called an anion. So now I can also lose electrons. Let's say I'm going to use a different example here. Let's say I have 11 protons. Those are positive. And I had 11 electrons, so I was neutral. But let's say I lost an electron. So I had 11 electrons. Let's say I lose one. I'll say lose 1 electron. So now I have 10 electrons. Remember, I always keep the same amount of protons or else my identity changes. So what is 11 minus 10? Well, that's a positive 1 charge. So if I lose electrons, so if my electrons are less than the number of protons, which it is here, electrons are 10, protons are 11, so electrons are less than protons. I then have a positively charged ion. This is called a cation, not a cation. I had some students that were saying cations, and I was so confused. They wrote it down and I go, oh, cation. Yeah. Okay, so let's look at this one. How many electrons are in a neutral bromine? Pause the video here real quick and find bromine and tell me how many electrons are in a neutral bromine. Okay, I found bromine on the far right. It has 35 protons. So in order to be neutral, which is 0, I got to have 35 electrons. What about a neutral aluminum? Well, if I find aluminum, aluminum has 13 protons, so it would need 13 electrons to be neutral. Overall zero charge, so 13 electrons for aluminum. How about if I have bromine with a -1 charge? So here's how I like to set it up. Let's change the color here to blue. If I have 35 protons, then I need to figure out how many electrons to have a -1 charge. See how I set that up? Because my electrons are negative, so I'm just going to think about this. 35 minus what is -1? So we need to go, oh, that would be 36. 36 electrons would give me a -1 ion. How are you feeling about that? Let's look at this one. How many electrons are in aluminum +3 ion? Okay, well, let's look at this. We're going to take this example up here. So aluminum always has 13 positives. So how many electrons to have a +3 cation charge? And if we look at this 13 minus what is 3, hopefully you said, oh, 10. 10 electrons would give me that charge. Let's look at this one. What is the ion containing 9 protons and 10 electrons? Well, let's write down 9 protons, 10 electrons. 9 minus 10 is -1. All right, so we know its charge is -1. How do I figure out the identity of this ion? Well, 9 protons is who? Well, that's fluorine, right? So it's fluorine with a -1 charge. What about this one? Which ion contains 18 electrons and 20 protons? Why don't you pause the video here real quick, figure out what is the ion's charge and what element are we talking about? Hopefully you found that 20 protons is calcium. And if I have 20 protons and 18 electrons, I have a +2 charge. Okay, let's move on to neutrons. So if I add up the number of neutrons and the number of protons, that gives me the mass number. Because remember, going back to that slide, the mass is found in the nucleus, and the nucleus contains protons and neutrons. We're not adding in electrons mass. Remember, it took over 1,800 electrons to have the mass of 1 proton or 1 neutron, so we're not counting it. The mass number distinguishes between isotopes. Isotopes are atoms of the same element that have different masses. Okay, so it's written behind the full written atom name or as a subscript in the superscript in the upper left-hand corner of the symbol. For example, if we say bromine 81, see how it says behind the full written atom name. So right here, this number right here is telling me mass number, which is protons plus neutrons. Or it's written, bromine 81 written like that, could also be written Br, and then we said in the upper left corner as a superscript. So we could say 81 like this. Okay, now how do I figure out how many neutrons are in bromine 81? Well, I have to find bromine on the periodic table. How many protons does it have? It has 35. That's its atomic number. So if I take that full mass, 81 as protons and neutrons, let's subtract 35 because that's how many protons it has, and that will give me how many neutrons it has. So let's do that math real quick. And we should get 46 neutrons. And I ran out of space there, but NEU for neutrons. All right. What about in uranium 235? All right, let's find uranium on the periodic table. It's way at the bottom. It's in the inner transition elements on the bottom in the 7th row, number 92. So this 235 is protons and neutrons. I'm going to subtract 92 because that's how many protons it has. So that'll give me 3, and then that'll give me 14, right? Yes. 143 neutrons in uranium-235. Let's look at the next one. We want to know, what is the symbol for an atom with 20 protons, 18 electrons, and 21 neutrons? Okay, I'm going to start with 20 protons. What element is that? I'm going to find number 20, which is calcium. Okay, calcium. Now notice, I have different numbers of protons and electrons. So let's figure out what that ion charge is. If I have 20 protons, 18 electrons, 20, positive 20 minus 18 is plus 2. So I'm going to write that right here. Okay, and 21 neutrons. So let's figure out its mass. 20 protons plus 21 neutrons, so 20 plus 21 is a mass of 41, which will go on the upper left-hand side. And they didn't tell us yet, but on the bottom left-hand side, as we can write its atomic number. We don't have to, because just by writing Ca, we can look at the periodic table and say, oh, calcium has 20 protons. But it can be written like that as well. Let's do this one. Why don't you pause the video here and write the symbol for the atom with 9 protons, 9 electrons, and 10 neutrons. Okay, a couple different ways we can do this. If you left it as looking at this and going 9 positives and 9 negatives, oh, it's neutral. Right, so we can just write F and then look at 9 protons and 10 neutrons. We can add those two together and say, oh, its mass is 19. So put 19 in that upper left-hand corner. If you want to put its atomic number down here, you can. You don't have to. If you want to write it like this, great. Or, since it was neutral, we could also write it in this linear way that we did up above for bromine 81. We could just write out fluorine dash 19 because that's its mass number. So either one of those is fine. Okay, why don't you tell me how many neutrons, protons, and electrons are in this isotope of fluorine? So take a second, pause the video, and tell me how many protons, neutrons, and electrons are in that isotope and ion. Okay, hopefully you found this out. I'm going to look at, first of all, I like to find F on the periodic table, and I see that it is atomic number 9. And then I'm reminded, oh yeah, that's what that 9 is. That 9 is the number of protons. And I'm just going to put a little positive P next to it to help me remember. Protons are my positive. Okay, now this -1 tells me it's charged. So I'm going to go up here on the top of the screen, and I'm going to say I have 9 protons. How many electrons do I need to have a -1 charge? Well, that means I must have 10 electrons because 9 minus 10 is -1. So 10 electrons. So we've got our electrons, we've got our protons. Now we need to find neutrons. Remember this guy right here, the 17 in the upper left, that tells me it's mass. That's protons and neutrons. So if I take 17, which is protons and neutrons, minus my protons, which is 9, that would give me 8 neutrons. So I got my protons, my neutrons, my electrons. Great job. Okay, and this is just a reminder. This top number is my mass number, protons and neutrons. Bottom number is just the atomic number, which is protons. All right. Take a second here. Here's a little quick check. How many protons, neutrons, and electrons do both of those atoms have? Okay, let's look here. Neither one of them are ions. So the first thing I did was say, oh, then my protons and my electrons for each are the same. So I looked up nickel. That bottom number, remember, for both of those is the atomic number. And atomic number is protons. So protons and electrons are going to be the same since they're neutral. And then to find my neutrons, you can see over here, I did the mass number minus protons to get neutrons. So 34 for the first one and 62 for the second one. So here's another, just a little example looking at mass numbers. Carbon 12 has 6 protons, 6 neutrons. 6 plus 6 is 12. That's its mass number. Now what if I had another carbon, carbon 13? So its mass is 13. So 6 protons, 7 neutrons. I could have carbon 14, 6 protons, 8 neutrons. So when we have elements with a different number of neutrons, they're called isotopes. Now notice that when you look at your periodic table, if I look at carbon, underneath of carbon it says 12.011. Well, that 12.011, I can't have 6 protons and 6.011 neutrons. I can't have a decimal or a fraction of a neutron. They have to be whole numbers. So why on the periodic table are they all decimal points underneath of those atoms' names? Well, they are averages of all of the different isotopes that are found. And we'll get into that math in just a little bit. So let's try this. I want you to pause and answer this question. Of the 3 major subatomic particles, the least massive is? That's right, the electron. What about this one? Which of the following is true? Boron 10 has 10 electrons, boron 11 has 11 neutrons, boron 10 has 5 electrons, or boron 11 has 11 protons. Take a second, pause, and hopefully you found that boron 10 has 5 electrons. What about this one? How are chlorine 37 and calcium 40 similar? Pause, figure out. Hopefully you found that it has the same number of neutrons. And that wraps up Chapter 2, Section 1